Hi everyone, welcome to today's session of AI Explained. Thanks to everybody who's joining today, and thanks also to people who may be watching this recording afterwards. Today, it's my great pleasure to have with me Dilek Haqqani, and we're going to discuss challenges and best practices for conversational AI. I would love to have Dilek introduce herself. Just before that, just a brief intro of myself. My name is Krishnan Kentapedi. I'm the chief scientist and chief AI officer at Fiddler AI. As you perhaps know, at Fiddler, we provide tools for explaining, monitoring, and broadly like managing deployed machine learning models in enterprises. Dilek, would you like to introduce yourself?
Hi, Krishnaram. Hi, everybody. I'm Dilek. I'm a scientist at Amazon Alexa, focusing on natural conversations, engaging conversations, and knowledgeable interactions. I've been working in the field as a scientist for quite a long time. Before at Google Research, Microsoft Research, and even before that, AT&T. And looking forward to the discussion.
Thanks, Dilek. Yeah, and as Dilek was alluding to, Dilek has a very rich experience working on several different aspects of conversational AI, ranging from like speech-related aspects to NLP and the blend of the two. So, given your experience working with several different organizations over the years, what are some of the common challenges do you see when companies want to adopt or deploy conversational AI aspects? Maybe before that, what do we mean by conversational AI?
Really good question, the last one. So basically, conversational AI is this field aiming to build agents that can help users, humans, interact with machines. These could be, there are different types of agents. These interactions with these agents could be more regarding completion of a task that the user may have in mind. Usually in the literature, in the dialogue literature, we call them as task-oriented dialogue systems. So they may be trying to, for example, buy some tickets or get their bill paid and so on. Or they may be talking to these agents to get, the customers may be talking to these agents to get more information about a topic, dive deep and then learn more about things they have an information need for. There are also more social conversations. They are also supposed to be informative, but also engaging and entertaining in addition to being knowledgeable. And going towards the challenges. So this is kind of like the way that we see dialogue systems or conversational systems in our minds. As scientists, as engineers, we just build, because each of these requires some different solutions. So maybe one of the challenges is from the user's perspective. When they come and talk to the conversational system, it may not be clear to them what this system can accomplish or what it cannot accomplish. So this is like one of the challenges. Either just bringing all of these together in one system is challenging, certainly, because each area has their own challenges, or if it is just one of them, clarifying it to the user, enabling the user to achieve what they are trying to achieve with the system, with the boundaries, with the limitations of the system. So these are some of the challenges. But besides that, as we go deeper, like there are all forms of challenges in terms of like recognizing the speech, which can be noisy or ungrammatical in conversational speech in some cases. Understanding that ungrammatical or noisy speech output, providing the user what they want, interacting with resources to help provide what the user may want. These are some of the challenges. Language is quite complex.
Yeah, yes, language is yeah, it's very complex, right? And that too, like often, especially like as we go beyond maybe grammatical or well-formed sentences to even conversational language, it becomes even more complex. Also, like when we often hear about, say, conversational AI or conversational systems, and we also hear a lot about chatbots. Is there kind of, is one a superset of the other, or are they similar? Like, how would you frame them?
Maybe conversational AI, in my mind at least, is broader. Chatbot is like something that you talk, is kind of like social conversations. But sometimes people use it for the purpose of task completion as well. Yeah.
Yeah, right. So like, yeah, often when we think of chatbots, at least like my mental model is more like we are just interacting through a text-like interface.
Hmm.
And I don't know whether that's how people usually like think of chatbots, or it could also be just over voice, for instance.
I imagine it could be, yeah, it's hard to come up with the right definition. I think they are both used interchangeably. But yes, certainly a lot of the chatbots that we use these days are using text, mainly text.
So talking of, as you're kind of briefly alluding to, the fact that language is so complex, right? Like I think, like, you know, in our when we just discussed a few days back, we were kind of thinking of these aspects, right? How well do whether it's large language models or even traditional models understand human language, like, are they just looking at statistical patterns, and are they behaving like what this famous paper talks as stochastic parrots? I think that's something for maybe for us to reflect more on.
Yeah, that's a good question. So these models are certainly trained to estimate either the following words, the large language models, or um, terms inside a sequence and so on. But they represent both the context and those words in terms of they learn representations for both of them, right? So that means they can generalize, they can learn to represent similar contexts or similar targets in the same way. That means they can generalize beyond what they have been taught. They can produce things beyond what they have been taught. But that said, they do not generalize, for example, to things that haven't happened yet. So when I talk about it, like in conversations, as we talk about the knowledge, the world, everything changes, right? So they are trained with some certain type of data, and the real world changes. So being able to really reflect accurately or respond accurately, I think they need to do more than just learning from some pre-existing data and get some connections to some APIs, to knowledge that keeps changing. Maybe even sensors, like, for example, if you ask me whether today or 3 months ago it's going to be different, I'm not going to give the same response. And there could be like sensors or maybe knowledge that one gets from the web that is about the current weather. So they should certainly be integrating that type of things to be able to be more accurate, more and be able to generalize to them. So since that knowledge changes, they should be able to do the matching, do the integration in an accurate form. That said, even understanding language is kind of a vague term in the sense that it's not clear that each of us do understand it in the same way. Like us humans, even when we communicate, there are a lot of misunderstandings. In the literature, we refine understanding in a more maybe closed fashion in terms of like what is the intention of the user, what are they exactly trying to do. And certainly these models do show strong performance in that type of at least shallower representations of language.
Yes. I think on the one hand, some of the developments in this kind of field over the last 10 years is amazing, right? I recall a few years back, the then head of Microsoft Research, Rick Rashid, gave a talk, I believe in Beijing or somewhere in China, and as he was talking, it was translated in real time into Mandarin, right? I think something like that, no one could have thought of, even say maybe 15 years back. So it's kind of, from that angle, it's impressive the kind of developments that have happened in the last few years. Like the fact that today it is fairly realistic for two people from completely different cultures, speaking different languages, to have a meaningful conversation with each other in real time, right? I think that's really powerful. At the same time, as you said, these models are often understanding at relatively shallow level, right? Like they are they're looking at statistical patterns. Even I recently saw on LinkedIn or Twitter somebody posting that even for facts that we don't expect to change, for instance, there was a post wherein you ask one of these models, right, like ChatGPT, what's the capital of Turkey? Then it gives the right answer. But if you ask, is Istanbul is the capital of Turkey, right? And then it says yes, and then gives gives a reasoning, very authoritative reasoning as to why it thinks that that's the case. It's kind of really interesting how, especially like when these models try to mimic the way human text is written, right, in a little bit authoritative and very convincing manner, it can even mislead people into thinking or concluding wrong facts instead of the right ones.
Misinformed, absolutely. That's a great example. Yes, and sometimes they can even insist that that whatever the misconception that they have is accurate. But at the same time, Krishnan, I don't exactly compare them with humans, because us humans, we don't have the ability to consume all of world's knowledge, whereas these models are trained with so many things. That form of hallucination is especially dangerous in a way, right? Because like as a human, I know Istanbul is not the capital of Turkey, but there are certain things that I don't know. And I may actually be convinced what the model is saying is true because they sound very convincing. So yeah.
Yeah, so I think this is something that even from a technical angle, I'm noticing that people are highlighting. There was a paper that we were looking at, which is highlighting how to quantify uncertainty for large language models, right? Even in when ChatGPT came out, in Andrew in the newsletter on deep learning was highlighting that. Being able to articulate when they have doubts is important. Otherwise, like if for every response, if they provide a very convincing response, that could be problematic, or that could even be dangerous, right, when it comes to
very misleading
and right, like on even health related or other aspects. So going maybe let's we can kind of, maybe if there is interest or time, we can go back to these kind of generative AI or large language models. But going back to say the aspects beyond just language, right? Like when we think of conversational AI, speech is an important aspect. So I remember you were kind of highlighting the need for understanding the spoken conversations as well, right? Like, could you kind of maybe elaborate on that?
Yes. So we often take the perception that like we do consider a spoken dialogue system as a system that is like a text-based system connected with speech recognition. However, speech is challenging. Speech recognition introduces errors, issues, and there could be like background noise. Maybe the speech is not clear, the utterance is ungrammatical. There are all forms of issues around that. Speech recognizers still do make mistakes due to a variety of reasons, which may distort the input to the conversational system. But there are also other issues, as you have in your in the notes. just the word sequence may not represent exactly what has happened. It may not capture the emotion of the user. Whereas if you listen to the audio, maybe the user is indicating something. It doesn't capture necessarily the sentiment due to the features. Just the word of sequence of words is not sufficient. It does not capture the tone. Like, for example, you may say the same sequence, but it may be a question versus a statement. Like I may be saying right or right, making more of a statement that is accurate. So each of these things are lost in that translation from the audio to the sequence of words, unfortunately. So that brings some additional challenges as well.
So yeah, I think that's a really interesting and subtle point, right? Like there's so much, there is a lot of signals present in the speech element, which can be completely lost when we translate them to text, right? Even if we include like intonations, or even if you say that, oh, there's an exclamation afterwards, there is a lot more richer signal in the speech itself. So talking of which, do you see a trend towards like maybe multimodal models, right? Like models which may directly take this raw speech and not necessarily convert them into text first and then process the text, but do the processing in one go or in a joint fashion?
That's a possibility. So in that sense, multiple modalities could be useful and then could be enriching each other. At least on the just the conversational interaction side, like that's why we sometimes like, okay, like we can solve this together, like let's just get face to face told together. So there is certainly some information in the multimodality channel as well. But I do think that on the output side, there is also some possibilities, some richnesses just via speech. Like a picture is worth a million words. Just via speech, we may not be able to represent anything, but most of these devices do have screens, for example. Multimodal information supplementing the speech could be super useful, is actually super useful. So there are, I think, like more opportunities. Should we represent them all together in one hop or in an end-to-end model or separately? That is certainly a very good research question. That's certainly a lot of work along those dimensions.
Yeah, yes. At the least, if I may rephrase what you're saying, at the least, we need to capture these other modalities, right? If there is visual signals or audio signals, there is no reason not to leverage those signals in addition to the text extracted from our audio. So going beyond multimodality, I think we kind of briefly discussed the factual accuracy, right? Like, maybe can you elaborate on what are some of the challenges, even when it comes to ensuring that the response is accurate?
So my thinking is each of these responses, even if they are they are generated by these generative large language models or other, they should be accurate. We can't just tell, like, a conversational system cannot just misinform a user. There are like lots of consequences that could come out of that, or people wouldn't use it if they're not producing. We wouldn't use them for the purposes that they are built for if they are not producing accurate information as well. So factual accuracy is very important. And it has different indications. Like, for example, for large language models, factual accuracy, like one approach that multiple people, including us, use is grounding the responses on knowledge. So the goal now is not to generate a response appropriate to the conversation context, but a response appropriate or relevant to the conversation context that is grounded on some knowledge that is also relevant to the conversation context. So that's one way. I think, because you brought up the speech, it is very important, especially in spoken dialogue systems, to provide not just maybe part of the needed information, but to provide it fully. Like if somebody asks you, when is the train to London taking off? 6 p.m. may not be a great answer because there may have been some speech recognition errors. Maybe it misunderstood London as some other city, and then it may misinform the user. So factual accuracy is important. For some systems, it can be, even if it is inaccurate, like the system should provide some visibility, broader visibility into the information that it is providing, especially for speech scenarios, so that it doesn't mislead the user. So it's really a broad concept that can have multiple implications, like with respect to large language models or with respect to spoken conversational systems.
Yeah. So is it, if I understood this right, is it more like instead of saying 6 p.m., if the response is the train to say
London is taking off,
then you can be kind of more sure that this is indeed the right one. Instead, say if the response is the train to Paris is at 6 p.m., then you realize that no, that is maybe the system did not understand my question right? At least you can recover from those mistakes made by the
exactly. System. Exactly. At least it gives the user a chance to say that, no, I didn't mean London. I didn't mean Paris. I'm talking about the train to London. And then at least it gives a option so that we can recover from that error, even if it is inaccurate. Yes.
So it looks like in a domain like this, the user experience aspects, right, especially the human-centered user experience aspects, maybe at least as important as the factual or the technical correctness of the response, right? Like how we present the response, how we maybe from time to time gauge whether the user sentiment, whether they are benefiting from that, all those things may be at least as important as just the response itself.
Exactly.
So along the lines of say factual response, right? One of the challenges that often happens is if say models, whether these are conversational AI models or even traditional machine learning, other machine learning models, work well for certain groups of users, but not for other groups of users, right? So this is often what we refer to as maybe bias in machine learning or the need for fairness in machine learning. So how do you think this applies in the conversational AI settings? What may be some of the challenges of this?
That's a very great question. And it would be great, Krishnan, because you're very knowledgeable in these areas, if you contribute to this response also. Yes, in the dialogue systems, for example, for speech, there are different languages that do not have enough representation in terms of the amount of data that they have, right? And then speech recognition should be equally accurate for those situations. Or same thing for accented speakers. Like, for example, I do have a certain type of an accent which is different than somebody else's, and then each of these are represented in different proportions in the data. There could be other forms of biases, like maybe I refer to certain things in a certain way, which is not aligning with what the rest of the population is doing. Going all the way to the intentions that I have, maybe my intentions are not really representative. So it should be possible to be equally accurate on each of these different setups. I can imagine there are others as well, but I would love to hear what you have to say on this also.
Yes, I think it touched upon some of the key aspects, right? First one is if you think of language, the availability of information or resources on the web is not necessarily correlated with how much a language is spoken, right? So naturally, like if you take a language like English, there are a lot more resources, and because this is spoken in relatively perhaps more developed and richer parts of the world. And as a result, there are a lot more resources, a lot more when it comes to linguistics or even just the content out there on the web. On the other hand, if you take some language which is still spoken by a large population, there may not be, if that population is from relatively lesser developed regions, there may not be digital representations of those. That itself creates a disparity. On top of that, even if we assume that we have information digitally or on the web, which is proportional to the number of people that speak a language, there is still a problem because I don't remember the exact numbers, but there are so many different languages in the world, and many of these languages are in the long tail. They're spoken by a very small set of people, right? Which means that there are, even if we collect all the resources, we collect the labels, training data from these groups of people, or from that dialect, the people who speak with some dialect, still there may not be we may not have enough, right? I think that's a real challenge. Even yesterday I was reading a criticism on, or some of the challenges associated with large language models, and one of the criticism is that these models work relatively well for English or languages that have a lot of resources, but as we go to this long tail, there is a big problem, right? We don't have resources. I think that's one type of broad structural kind of biases, right? Or these differences. The other aspect is, even if let's even take English, and let's even confine to just the English spoken within United States. What I hear is that there are lots of differences in the accent, even in different states in the US, right? Like the way the English is spoken in southern states could be very different from the way it's spoken in northeastern states or in the West. Making sure that the model works not only as a whole, but also for each of these subgroups is very important. And perhaps even more important is making sure that that's the case even after the model is deployed, right? Even over time, even though the model was stress tested for different types of biases before deployment, making sure that we continue to monitor the model and make sure that the model does not develop new types of biases over time. I think that's important. And of course, there are several other dimensions, like many of the protected categories, like gender, age, ethnicity, lots of different factors might come into the picture. But in addition, in the case of language, like notions like dialect or maybe background noise, right? Like robustness to all these different aspects becomes important.
Yeah, absolutely, absolutely.
So by the way, let me just note that for all the attendees, please feel free to post your questions on the Q&A, and we'll be happy to just discuss those questions along with the rest of the conversation. Yes, please feel free to post any questions, and that way we would love to make it as interactive as possible. Just like bias, I think another challenge is how to handle, or how to kind of gracefully handle complex failure modes, right? Like, I think that's something which seems a little bit unique to conversational systems.
Yes, exactly. I mean, any model, any system, in my opinion, should be trained to at least recognize what it doesn't know, and then give feedback based on that to the user. For example, it may be a user intention that is not in domain in terms of the intentions that the system developer already designed. It is important to have integrating some, like maybe other, like recognition of these other intents that says, okay, now I don't know how to do that. It's not really the duty of the system. Or integrating some out of domain detection tools that would say that, oh, this intent is not covered by this model. This is one thing. Providing more information, although like in that example from London to Paris, providing more information in the output, in the responses, could be like one way of mitigating complex failures also, so that the user understands, oh, there's something wrong here. I should try and correct. These are all like some ways, but yeah, I think the systems should be designed as much as possible to tackle these error cases. to correct these errors or enable the user, because it's a conversation at the end of the day. It's not like done. You can try and correct the misunderstanding. So they should be able to forget things, for example, that cause them the error, but focus on the new information.
Yes, and even when it comes to such complex failures, even ability to handle a little bit of adversarial scenarios also becomes important, right? Like I think a few years back we had presented a tutorial on fairness in machine learning, and one segment of the tutorial was around what is fairness or responsible AI mean in the conversational agents setting. So let me see if I can share these notes. I'm able to share with the host and panelists, but if one of the folks from the Fiddler side can post it or share with the attendees afterwards, that'll be great. So here, I think there are kind of different types of harms that we were kind of discussing. For instance, how do we ensure that the conversational agent does not misinform the user about the status of some task or the capabilities, or even does not accidentally reveal, say, sensitive or private information, right? I think one example I remember is, say, you ask for what is Bill's number, and the intent is what is the Bill's phone number, and instead the model responds by providing the credit card number, right? And that's something that we don't want. I'm sure there are no models, deployed models today, that are as bad as this, but this is just a contrived toy example, right, where things can go terribly wrong. The challenge is when these kinds of failures or harms occur for certain subgroups of users more than the others, then it becomes more problematic, right? That could be perceived as like more like bias. Yeah, in that tutorial, we also briefly discussed about harms at the social level. These could be like harms to individuals or harms to communities. The harms to individuals could be harms like, say, if the chatbot or the conversational agent encourages certain types of behavior, like maybe self-harm or violence, wherein the user might have started with something which might be a little bit in the gray area, and the model then suggests more and more of those kind of things, which leads to this kind of extreme behavior, right? Or discouraging good behavior, such as visiting doctors or taking up vaccines, right? I think there are those kinds of harms, and even like social harms, like, say, promoting violence or engaging in hate speech. These are all, I think, quite complex topics. There is often the models may not have encountered those before deployment, and that's perhaps yet another reason to monitor for these kinds of undesirable behaviors after the model gets deployed.
Yes, absolutely. Like for example, large language models are prone to capture the bias because they are scraping data, using data from all over the web, and they can easily capture certain biases, conscious or unconscious ones, and they shouldn't be reflecting these in their responses, causing social harms. So there are possible options in terms of like detecting like things like self-harm. So it should be possible to detect some of these, either because it can come from the user's request side as well, or in the response, and then act appropriately, overriding whatever the model is generating, but also improving the model, giving it feedback back to the model to correct that type of behavior that is not desired. But these are like super important issues, basically in terms of responsibility. It's a responsibility for the builders of these systems to avoid these cases.
Yeah, and some of these cases can be quite tricky, in the sense that say we may want to, in case, say, from in the past, the conversational agent behaved in a provided undesirable responses, we may want to filter out those outputs of the agent when it comes to retraining, but we may still want to keep the inputs to the model, right? For example, if, say, let's say that somebody issued a racist or hateful comment to a conversational system, the model may not have responded in the best way, right? The model may have said something like fine or okay, and that may not necessarily be the optimal response. But we may still want to keep the inputs when it comes to retraining and making the model more robust, but we may not necessarily want to keep some of the outputs if they're not the best or the desirable outputs. So one of the questions I see is, how do you recommend minimizing risks in such models before we launch conversational AI applications? Maybe that kind of brings us to moving from challenges to best practices, right? Like maybe could you just walk us through some of the ways to minimize such risks?
Yes. So we do build a bunch of classifiers that would detect each of these cases. And depending on the type of the case, come up with better responses based on the case. Recently, we did some work on basically what we call as guidelines. You do let people write a bunch of guidelines, especially the developers. Like if this comes up, don't say that, but correct the response in this fashion. Without even having to retrain the model, one can add a bunch of guidelines to the list of guidelines and then correct the inaccurate behavior of the model in that fashion. This is like yet another approach. When a new conversation occurs with the response or with the context, you can try to find the best guideline for that is matching the setup, and then correct the response accordingly. Others have tried different methods, like preventing them at decoding at the generation time, for example. So there are a bunch of solutions that I can think of to avoid this form of bad cases.
So more broadly, like what may be some of the as kind of practitioners, right? What are some of the things that we need to keep in mind while building and deploying conversational AI applications?
You mean in terms of like these biases, or in general?
More in general, right? Not just biases, but if let's say that somebody is interested in building a conversational AI application for a specific type of tasks, what are the things that they should keep in mind?
I think we should, yes, like the most important thing is like determining what the system should do, and then ensuring that we have enough support for those things that the system is supposed to do. So if it is a booking system, we should ensure that there is some information that can accurately retrieve in all forms of combinations the booking information, and then also determine like what are things that are out of the scope. Like, for example, if somebody is gonna ask, is there AC in this train, that's not really related to necessarily booking, but it may be a frequent request by the users. So make a decision whether to integrate that or not, and then if integrated, at the appropriate backend knowledge or resources about that. So I think this is one kind of like important area, and if the system is not supposed to cover that, then have a message like, okay, this is not what I do, but I can do this other thing. Of course, depending on the customer interests, the distribution will change over time, looking at the data, making sure that the things that the users are having more need on and extending the capabilities towards those could be something. Formulating, making sure that the responses are accurately reflecting the truth. They're not capturing like these biases, misinformation, unsafe responses. Ensuring that is yet another thing that we should be paying attention to. If there are possibilities that things could be understood, that getting them, maybe having some like classifiers or detectors to detect them and prevent them before is I think a good responsible approach. Yeah, so these are the things that I could think of right now, but
Yes, I think those are fantastic suggestions. That brings me to another question that I see from one of the attendees. How can we approach, say, corner cases or edge cases that could impact model predictions if we miss including some text during training?
I imagine this is corner cases in the input data, right? Or training data. I think, and then I think there are corner cases in the output traffic also. But the usual approach that I think of is I wouldn't exclude them, but I would think of, especially if they are going to be in the coverage of the system, I would think of like maybe creating similar examples using some data synthesis methods, or they are not, they are represented enough in the data and they are captured. If it is not in the scope of the application, it's a corner case that we want to have a direct, like, okay, this is not something that we do, then maybe including them in the data, but telling that this is like not something that the system is supposed to cover, depending on the type of the system. If it is like doing intent recognition, for example, mapping them to the other intent, or if it is an end-to-end system, then drafting responses that are like, this is not in the coverage of the system, could help in there. Corner cases, a lot of things that are not covered by these models do happen with the actual traffic. So once launching a system, it's important to see like what is happening in the traffic, grouping these things using maybe automated clustering methods, grouping these things that may happen frequently, but somehow we did not capture in the model design, is usually useful to go back when going back and updating and improving the model.
Yes, I think this is really interesting in the sense that sometimes we may not know those corner cases until after deployment, but as we discover such edge cases, it's a good idea to figure out how to handle those, right? Whether we need a separate model to detect those edge cases and maybe redirect to that fallback model, or do we need to incorporate maybe related examples in the training data and retrain the model? Like there may be several different ways of addressing these kind of edge cases.
Exactly. Like one of the most common things that I see is users may be asking something that you haven't envisioned before. It's very easy as a system designer, like, because we are so focused on what we designed this system for, but there may be other user intents that we haven't envisioned, at least during the development of this system.
Perhaps a open question or an interesting challenge is what to do in those cases, right? Let's say that we build, as you're alluding to, we build a conversational system for completing a booking for maybe a concert or for train tickets and so forth. And if people start asking about reviews suddenly, right, which is not under the purview of this task, how do we handle that? Do we expand the system scope, or do we somehow nudge them to somewhere else for the reviews and still focus on the task?
Yes, yeah. This is like something that I have focused a lot on my research work, that like, what do we do in these cases? Can we actually detect these intents? And then can we find other resources? For example, back at Microsoft, we did have search logs, and some of those intents that we do not envisioned before could be appearing in the search logs, and it would be possible to group the search intentions and then and integrate them into the system. So it can be similar, like for a company, if they have usually companies have their search boxes on their web pages also. So there may be queries coming in there, and maybe possible to cluster them, group them, to see if there are interesting things that should be included in the conversational system. More recently, though, we are looking more into like, okay, yes, there may be other intentions, user intentions that are not covered, for example, by the APIs that we have built. For example, for a train information system, as I was mentioning early on, people may come and ask additional questions like, can I bring my pet to the train? Well, the train timetable, the database doesn't certainly have that type of information, but similar information could be found on the web. Like maybe there's an FAQ page that is answering to this form of questions, or maybe there are customer reviews that are saying like, oh, the train didn't have an AC, it was hot, and so on. So it can also be possible to detect these things and then match them with textual resources, and then come up with additional answers, so that the user comes to the dialogue system with an intention, but they have some additional questions to complete that intention. Then we can use the resources on the web or documentation, internal documentation, to help with the completion of the task. It's not an easy thing. We have been looking in this for some time now. We've been coordinating challenges, public challenges on these tasks, like how to integrate information from documents, or how to integrate information from customer reviews. This last one is happening as of right now. We did release some task-oriented dialogue data sets with a large set of reviews. And then in the data sets, there are customers asking things that could only be answered if you look at the customer reviews and then come up with a sufficient response from them. Certainly a challenging task, but yeah, I think the state of the art is improving slowly in these areas.
Yeah, yes, absolutely. Yeah, so let me just remind the attendees once again, if you have questions, please post in the Q&A. So one, while we're waiting for more questions, the one, as you're discussing search, one of the things I remember when working on web search related domains was that sometimes the tasks might span even months, right? Let's say that if I'm planning a vacation in Indonesia, I'm not going to make the decision in just one session. I may start asking some questions first, maybe even start with, okay, if I'm thinking of that region, which are the countries that I should consider visiting, which are the cities I should consider visiting, then that goes gradually morphs into maybe more specific tasks, right? Like booking a hotel or booking flight tickets and whatnot. And when this happens in web search, often that spans several months. And in the midst of those, you would see other queries from the same user, right? So you may need to decompose the session into different intents or different tasks, which are kind of somewhat interleaved. Are there parallels in the conversational AI space?
Certainly. So there, for example, there is work on training models to have conversational memory, to capture information from past interactions, save them in a conversational memory, and then in the new session, like bring them to the context of the new conversation. Like, for example, if it is social conversations, the model, the system should not keep asking me like, do you have pets, or have you seen this movie? It should already remember. And if I have a pet, maybe occasionally ask if the pet was sick last week. I have been to the vet. Or ask about the status and so on. Each of these things, like the ability to remember what has happened in the past conversation, is an important one. There's certainly research on this area, a lot of work on this area, maybe more recently. And then similarly for task-oriented dialogue systems, like even as a user of ignoring the dialogue systems for a second, like tools or web forms out there, like if I go search for a flight, maybe I have searched something like 2 days ago, if the interface allows me to start from where I left off in the previous search, that saves me so much time. I prefer those interfaces way more in comparison to others that do not remember that information. So I think it is super useful to have something like that in general for all forms of conversational systems.
Yes, I think that that aspect of remembering the context becomes very important and also very convenient for the end user, right?
Yes. And then maybe in addition to remember, kind of like tracking it, because these facts, the things that we capture could change over time. Like maybe I do like something a month ago, and then maybe last week I mentioned that I don't like that anymore. Like the system should be able to kind of like track the situation, not have both forms of information in the memory.
So as you're alluding to some flavor of remembering the context, or even perhaps personalization. At a point of time, with regard to web search, personalized web search was a hot research topic, right? Like, are there parallels in the conversational AI world? Like, can I imagine a world where there is perhaps a large pre-trained dialogue or other kinds of models, and I can personalize or fine tune the model for the needs that I have? Is that even are we close to realizing such models, or is that just too far out?
It is, I think, conversational recommenders, for example, is an interesting, a useful area. There are some solutions, but I think it is still kind of like in the research stages. But you're absolutely right. Like, if the systems can kind of like get to know me over time, and then maybe based on what other people who are like me do, makes me suggestions, gives me outputs, responses based on those. That would be very, very, very useful.
So stepping back a little bit, maybe moving from the research to the actual business or application world. So one question I see is, let's say that we are building models and wanting to deploy or have deployed the models. How can we inform our business counterparts that the models are delivering on the business cases? Like, apart from showing that the models are performing or accurate as expected?
This is a good question. In the business cases, meaning, are they basically supposed to do what they are supposed to do, or is that what the question means?
Yeah, I presume maybe more like, say, let's say there is a conversational AI system for, say, maybe some specific task accomplishment, right? Like, let's say for travel booking. And how do we inform the business counterparts? Let's say, as data scientists developing these models, how do the data scientists then convince the business leaders or product managers and others that these models are delivering on the business use case, in this case travel booking? What would be a way to do that, apart from just showing maybe specific metrics like accuracy of the model, or right, like some of the there's a model specific metrics?
I see. I think, I mean, accuracy certainly is very important, keeping track of accuracy based on fixed test sets, based on the actual customer use cases, computing the accuracy online based on the signals from the users, because the user may be indicating that they are not happy with the outcome, is certainly important. But beyond that, going to the data, going to the logs, analyzing the logs, what is happening, what percentage of the time did people do what, how long did the conversations take, what percentage of the time the users actually committed to what they were offered, and so on. Like, these are all forms of statistics that are very, very useful in just presenting. And actually, it can be useful for the system developers as well, because maybe the business use case has something in mind, but that's not exactly what the customers are looking at. Being able to present them to the business teams, and then adapting maybe the backend resources towards that. So the data, I think, is like, in general in conversational systems, the data is really the most important thing. It basically tells us what customers want to do, how they want to do things, where should the system go towards. It's tricky because it's a chicken and an egg problem. In the beginning, maybe the customers do try a lot of these things to see whether it's done. Maybe they try once and they don't, so we may not be able to recover. So customers may converge to certain things that the system can do well. So it's always important to look at those edge cases in the data, continuously monitoring what is happening. Is, I think, in general, like one of the big things that one should do for an actual application.
Yeah, yes, I think that's well said. So it's kind of at least as important to monitor or understand what users are looking for from the data, as opposed to just looking at whether the models, right, just the accuracy or those kind of very model specific aspects, right? Like I think always, like one thing I've learned even in my 2 years at Amazon is that working backwards from customers is so important. And in this case, the customers or perhaps the end users and maybe other enterprises using conversational AI systems, and understanding how they're benefiting or what they're looking for is extremely important. So maybe in the next just a few minutes, so going back to something that we were discussing at the beginning, right? Like over the last few months, we have seen the emergence of so many large language models, or more broadly, large pre-trained models, like often called foundation models or generative AI models. What are some of the implications of such models when it comes to building conversational AI applications?
It's a very good question. It's certainly very exciting days for the field of conversational AI in general. I have never seen, over the past many years I've been working on the field, I have never seen this much interest, which is exciting. And actually it's kind of like more exciting days are about to start, given the abilities of these systems. I think it's important to be able to benefit from these models as much as possible. Because, for example, now earlier we were looking into like the user intentions, arguments, and so on. Well, these models certainly do a good job in extracting them. They could be supplementary, they could be useful. They could be probed to generate, even without a lot of data, to generate these intentions and so on. So I think there are big implications, or they could be probed to generate annotated data that could be useful in our system development. So there are certainly big implications for the offline. Offline meaning the training stages of the conversational system. They could also provide additional information, or maybe in certain cases, if they are knowledgeable about a certain topic, they could be resources. They could actually revamp the whole conversational system by providing equally similar information, because some of these models are shown to generate pretty good in terms of converting natural language to code as well. It could be the API definitions, it could be database queries, or be just pure old code. And one of the biggest challenges in dialogue systems in general is these backend information sources. So then I think, in my opinion, these models are really promising for accomplishing this overall goal of like being able to present user or return to user for any form of intention that they have. But that said, there are also dangers, like we discussed in the beginning. Like, for example, they do hallucinate, they capture biases, and so on. So putting appropriate guardrails, doing more and more knowledge grounding, or doing more API integration to these language models feels to me is really going to advance the field significantly. It's very promising, very exciting days, certainly.
Yes, absolutely. I think we briefly touched upon this kind of wide disparity even across languages in the world, right? Like maybe, who knows, like as we see language models that combine multiple languages, right? Like maybe that might partly address some of these limitations. It could be a blessing for all the under-resourced languages in the world as well.
Exactly. Very good point.
So if you were to make maybe some broad predictions on where the conversational AI field is heading, what would some thoughts be? Like, what are the broad, where do you see this field emerging, both in the research and also in practical settings, maybe a year or down the line?
I think we have achieved a lot, but still we are scratching the surface in a way. I think and the one promising thing is like a lot of super accomplished people are really focusing these days on these problems. So I'm hoping to see some really big changes moving on, increased abilities, lots of different applications, increased interactions. There are, again, certainly challenges, so we should keep trying to improve these systems. But I'm quite hopeful. But there's like so much needs to be integrated. Like we discussed multimodality, we discussed speech and so on. So as each of these come together, hopefully we will have much better systems in the near future.
Yeah, yes, I think these are definitely very exciting time to be working on these topics. So I would encourage perhaps all the attendees, right, whether they are looking at it from a practical angle, implementing in deployed systems, or even from an angle of what are some of the challenges. There's so many challenges and exciting times ahead. Thanks again, Dilek. Thank you so much for joining this discussion today, and just making all of us aware about the challenges and some of the best practices and where these domains are headed. And looking forward to having more conversations with our attendees in the future.
Thank you so much, Krishnaram, and thanks to audience for the questions. It's been a great discussion.